I've received a question about this problem, which is 9.2, number 50 in the top right corner. So let me click on View an Example here. All right, the following data represent the asking price of a simple random sample of homes for sale. Construct a 99% confidence interval with and without the outlier included. Comment on the effect of the outlier, the outlier has on the confidence interval. All right, so look through the data set. It becomes pretty obvious. I mean, all the homes are within the $100,000 to $200,000 range, except for this one, which is at 459.9. So that is the outlier. So just kind of looking at it, you can tell that's the outlier. Okay, so now let's do a couple things. First thing they want us to do is construct a confidence interval that includes the outlier. So let me grab the tutorial video here. All right, so of course you don't, if you're working in my math lab, you don't really have to show all the steps, but you are going to have to show all the steps when you have to do this on an exam. So it's not a bad idea to kind of get into the habit here. All right, so we have to do some work on the side a little bit. The confidence level is 99%, which is 0.99. That means that alpha is 0.01 and alpha over 2 would be 0.005, and that's the column of the t-table we want to go to. And n is 12, which means degrees of freedom is 11, so we go to that row of the t-table. So let me grab the t-table. There we have the t-table right here. We want the 0.005 column, and we want the 11th row, which is 3.106. Okay, so that's T alpha over 2, 3.106, which leads me, by the way, to the formula we're using, which you can get from the inferential statistics sheet. We're making a confidence interval for the mean for one data set. So a single data set mean would be the T interval. So this is the formula we're using. All right, so let's figure out all the pieces and parts that we need. So if we look at the data set, right here. So we have this data set. We need to type this into the calculator. So I'm going to go to Stat, Edit, clear out my old data, and I'm going to type in this new data, 225900, enter 143. Pay attention to where you put the outlier of 1459900 because you're going to need to go back to it and delete it eventually. All right, let me type all this up. I'll be right back. All right, there we have it. I have all the data points in there. So let me bring the screen back. So you press Stat, you can go to Tests, you can pick number 8, which is the T interval. There it is. And since we had a column of data in our calculator entered, we want to select data. So you press Enter on the data, and it should be dark. My data was an L1, my frequency is 1, I had a confidence level of 0.99. Go down to Calculate. And there we have it. Okay, so let me copy this. Now, why did I do it that way? Well, because when I run the interval, it actually tells me X bar, S, and my N values, which are what I need in order to do this by hand. So my X bar, I now know, let me bring this down here. My X bar is 232,250 plus or minus. The T value is the value I found out before, 3.106 times S over the square root of N. S is 83020.2 over the square root of N, which is 12. So there I have that. And then my answer is 157,817, comma, 306,683. And there we go. So now for the second part, they want us to redo the whole thing, but take out the outlier. So we need to go back. Oh, and by the way, in case you're wondering, how could you find out if there was an outlier? I mean, remember we have a whole formal process for that back in chapter 3, but you can also actually turn on a scatter plot. So let me go down, or a box plot. Let me go to second stat plot. It's above your y equals, see it right there? I'm going to pick number 1. I'm going to turn it on. And then I want the one that is the box plot with the little dots after it. So you're gonna have to press right, get to the right to get to these. Even on the old 84s, that's how it looks. And then I'm gonna hit L1, that's perfect. I want the little box shapes, that's good. So I'm gonna hit zoom 9. There you have it. And you can see that the one outlier you have is over there. And you can press trace and hop along to the right to view the numbers. There you go. You can see it's that max of 45900. That's your only outlier. Let me show you what it looks like in an old 84. No. All right, so let me go to stat plot. Ooh, first I have to go to stat edit, enter the data in. So I'm going to pause. I'll be right back with that. There, I want you to see that we have the same data set in there. And then you can actually run the intervals just like you do on the color calculator. It's just that you have to kind of scroll down to see number 8 down here. So number 8, you want data L1, you want 0.99, go down to calculate. Oops, I pressed the wrong thing. My fault. 8. There we go. And there we have it. So there's the confidence interval, just like on the color calculator. And then now to turn on the box plot, go to second y equals, pick number 1. You want to press enter to turn it on. And then I know it seems like you could press down to get to that box plot, but you can't. If you press down, it takes you to the X list. So you actually have to hit the right arrow. And then once your cursor is blinking on the box plot that has the outliers, you want that one, not the other one. So the one that has the little dots on it, that's the one you want. Then L1 was where my data are, and then my mark is there, and so on. Zoom 9. See? Same picture. And you can still press trace and hop along and find what that outlier is. Its outlier is 459900. Wonderful. Okay. Okay, so now we have that done. For part B, they want us to remove that outlier. So I'm going to go back to my data set, stat, edit, and I'm going to move my cursor down to 459900. I'm going to press the delete key, DEL. There, makes it disappear. All right, so then I'm going to go press stat, test. I'm going to pick number 8 again, T interval, data, that's fine, blah, 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 enter. Okay, so you can see a whole bunch of stuff is changing. So let me write all this into the sheet we have going here. Okay, so the substitution now is, notice all the numbers are changing, and that's because you got rid of the high outlier. So the mean is no longer 232250, it's 211554.5455, but you don't need that, 0.55, how about that? Plus or minus, that number is different now. We'll have to figure that out. This number is now 43909, so it shrunk considerably because we removed the outlier. N is now 11. And that leads us to the t value right here. So you're supposed to have t alpha over 2, right? So we need to go figure that out for a second. See, your sample size is now 11, which means your degrees of freedom is now 10. So that would be the row of the t-table you would go to. So let me grab the t-table. I still want 0.005 because it's a 99% confidence level. So I need to go down to degrees of freedom 10, which is 3.169. So that'll be the number I put in, 3.169. And again, of course, my MATLAB didn't really need every little piece of this. MATLAB needs the results. However, you are going to need every single piece of this for when you have to take an exam on this. So you might as well know how to write it up. And what I am typing here is exactly what you write. I mean, there is not a single thing that I have typed in here that you would not be writing as you do this. This left-hand side absolutely positively must be shown for exams. The final exam on this material. Any exam on this material, you are going to be required to show your formula, substitution, and result. All right. So, I forgot to say that this was 3.169. Technically, it's an approximation because the table is full of approximate values. Wonderful. So now I imagine they want to know what effect this had, but let's double check all of our numbers just to make sure that we have everything right. So we said that this was the answer for the first part. So let me go back to the computer screen and make sure. Yep, 3.106, just like we said. And then 30666688. Yep, 3066. And now we have 83. That's probably due to a little bit of rounding error. Let's just double check it that it works. So if I take, let me grab this. Okay, so if I grab the calculator and I make it look at 23, stop that. There we go. 232250 minus 3.106 times 83020.2 divided by the square root of 12. Yep, see, that gets the 812. So there's a little bit of a rounding issue here because the calculator is rounding not only the s, but also the t value. Or, excuse me, the calculator is not rounding it. I'm rounding it here when I do it by hand. Whereas the actual answer, this one right here, has less rounding. So this is actually a more accurate answer. All right, then construct a 99% confidence interval with the outlier. Oh, let me just show you real quick that if you do it this way, then second entry gives you the same thing you just typed, and all you have to do is go change that minus sign to a plus sign, and you have it. Plus, enter. There you go. So this is from the calculator. So this is from t interval. And if you do it by hand, it's really similar, but it's not exactly the same. It was 812 over here, and I think 88 over here. Let me double check that. Yeah, 88 and 812. So there you go. So either way, my math lab, I would think would accept both, but if it doesn't, if they probably want the by hand answer on this particular one. Me, for an exam, I usually want this answer because it's better. It has less rounding in it and less error. All right, so then when I remove the outlier, we said the answer was this, but of course that is using t-interval again. There you go. Now if I type it in, let me grab the calculator. 211554.55 minus 3.169 times 43909.05 divided by the square root of 11. There, and you can see I'm very close to what I had before. It's just slightly different. So instead of 169566, I have 169599.9. So that's basically, that would all round up to 600, right? And then this number will be second entry, change that minus sign in there, go with your left arrow over there, change the minus sign to a plus sign. There we go. And we get 253509. There we go. Now let's see what else they wanted real quickly. So we've got their numbers. We remove the outlier. See, 253509. There we have it. And then comment on the effect of the outlier has. Well, when you remove the outlier, it lowered the mean for starters, but it also shrinks the size of the interval. So I'll write that up 1 second. All right, I typed them up. So the outlier being removed, or being added for that matter, changes where the center of your interval is because it's changing x bar. It also affects the standard deviation, the standard error, the margin of error. You could see the standard deviation went from 83,000 to 43,909, and that affects the standard error, which is s over the square root of n. It also is affecting the margin of error. Now remember, margin of error is half the width. So with the outlier, that's a half of this distance from the high end to the low end. And without the outlier, it's half of this distance. Let me find those two numbers. There you can see them entered into the calculator, I'm going to type those into my spreadsheet here. There you go. So you can see we have a much larger error / interval with the outlier and a smaller interval with more accuracy without the outlier. Hypothetically speaking, the latter is the better one.